Okay, so I'm going to continue to do a few more of the solving exponential equations problems from 4.3 and 4.4. I'm trying to keep the videos short, so I'll only do a couple of examples on each one. Just like we talked about on some of the other videos, your first thought needs to be to try to get like bases. If you can get like bases, that's what you want to do. We did some of that previously. But if you can't get like bases, then what you're going to do is solve them with logarithms. So if I have one like this, obviously I could rewrite 4 with a base of 2. That would be 2 squared. But 15 can't be rewritten any other way. So there's no way for me to rewrite this with like bases. So instead, I'm going to solve this with a logarithm. Now, you could solve it using common log or natural log, but for the purposes of these assignments on the computer, they solve them with natural log. So I'm just going to put a natural log on both sides. Because just like the laws of algebra have allowed us to do since we started taking algebra, as long as you do it to both sides, it's okay. So now I've got natural log of 4 to the x power equals natural log of 15. Well, the whole point in doing that is now I can use log properties and pull this down on the main line. So I have x natural log 4 equals log 15. And now all I have to do is just like all my old algebra rules tell me is get x by itself. So I need to get rid of this log 4. I'm going to divide both sides by log 4. And this is natural log of 4. Now, that leaves me x equals log 15 over log 4. Now this is considered to be your exact answer. So some of the assignments on the computer want your exact answer. And then after you've put in your exact answer, they ask for your decimal approximation. In order to get your decimal approximation, you just plug that value into the calculator and get the decimal version. So that's it. Those are the simple kind. So let's do one more that's fairly simple so that we have a little bit of practice. If I'm given a problem like this, now I can't rewrite this with a base of 10 because I have a 12 at the front of this particular number, so I'm going to have to write this as a logarithm. Instead of using natural log this time, I'm going to use common log, and the reason is because of all these zeros. If you remember, common log is the one on your calculator that has no base written, but it's really log base 10. So I'm going to write this as log 10 to the x power equals log 120,000. Anything you do to one side, you have to do to the other. Now the whole point in that was to pull this to the front. So I now have x log 10 equals log 120,000. Now right here we need to remember the property that we talked about the other day, that if a log has the same base as it does argument, that it equals 1. And in this case, there's actually a log base 10 there. So this is log base 10 of 10, which means it's 1. So I actually have x times 1, or just x, is log 120,000. And again, that's your exact answer. They may ask you for your decimal approximation. So that's solving simple exponential equations with logarithms.